Okay, so in this problem, we are going to solve the following question from this old national exam. Let me read the question for you first. The function f is given by f of x equals to this function as you see here, a times x minus a times x minus 2a times x minus 3a, which is also equal to ax cubed minus 6a squared x squared plus 11ax cubed a cubed x minus 6a to the power of 4, where a is a constant and positive. The graph of f intersects the x-axis in the points P, Q, and R, as you see here. Show algebraically that the tangent to the graph in the points P and R are parallel, regardless of the value of the constant a. Okay, so if I want to solve this problem, the goal is to show that two lines are parallel. If I want to show two lines are parallel, I should show that the k value, the slopes of these two lines, are equal. In order to find the slope of the tangent line, I have to calculate the derivative of the function, replace x in the derivative with the x coordinate of the point of tangency. So I need to know the x coordinate of this point, which is the tangency point for this tangent line, and I need to find the x coordinate of this point, which is the tangency point for the second tangent line. But because this is the x-axis and these points are intersections between the graph of the function and the x-axis, we know that the x-coordinates of these points are actually the roots of this polynomial function. But the roots of these polynomial functions are very easy to find, because if I want to find the roots of a polynomial equation, I equate it to 0, then I will solve the equation a times x minus a, x minus 2a, and x minus 3a equals to 0, and then I see that the product of four numbers is equal to 0. So this cannot happen unless at least one of them is equal to 0. But because it is mentioned in the problem that a is positive, this cannot be 0. So this means that either x is equal to a, or 2a, or 3a. So then I get three roots. X is equal to a, x is equal to 2a, and x is equal to 3a. But because a is positive, it is clear that a is smaller than 2a is smaller than 3a. So we immediately realize that the x coordinate of this point, so let me change my color to be more visible, so it shows that the x coordinate of this point is the smallest one, which is a, and the x coordinate of that point is the largest one, which is 3a. Okay, now I need to find the k value at p and at r. So what should I do? I need to differentiate my function. And that is the reason they have given you this function in two different ways, because in NpMa3c we don't know how to differentiate it, because that's a product of three functions. So we have to open it up by multiplying. To save you some time, the designer of the question has also opened it up for you, simplified it, so that you don't have to do it yourself. Okay, so I calculate the derivative now. The derivative of the function is equal to, so the derivative of this one is 3ax squared, and the derivative of the rest I will write it here. So it is 3ax squared. The derivative of the second one is minus 12a squared x, and the derivative of the third one is just simply 11a cubed. But the derivative of the last one is 0, because it does not depend on x, and a is supposed to be a positive number. It's a constant number, sorry. Okay, so this is your derivative. Now you have to find the k value at point P by calculating the derivative at the x coordinate of point A, which we got to be a. So what does it mean? It means that you need to go to your derivative, replace every x with a. Okay? So then it becomes 3a times a squared minus 12a squared times a plus 11a cubed. And this becomes 3a cubed minus 12. Oh, I don't know why I wrote to the power of 6. 3a cubed minus 12a cubed and then plus 11a cubed. Yes, so if you calculate this, 3 minus 12 is minus 9 plus 11 is 2a cubed. So this is the slope of the left hand side tangent line. Let us now calculate the slope of the right hand side tangent line. And this means that I need to calculate k value for point R. So I have to calculate the derivative at the x coordinates of point R, which is 3a. So this time I go back to my derivative, replace every x in my derivative with 3a. Okay, so this becomes 3a to the power of 2, and then I have minus 12a squared times 3a, and finally 11a cubed. Okay, so no, I made a little bit of mistake in my writing here, sorry. So let me fix it. Okay, so this should be a power of 2 up there, not there. So let me fix it. This is power of 2. So what I have to do, I have to replace x with 3a. Yeah, it seems correct. But this one becomes 9a squared, then it becomes 27a cubed. And the other one is minus 36a cubed. And the other one is 11a cubed. Okay, but 11a cubed plus 27a cubed becomes 38a cubed minus 36a cubed. It becomes simply 2a cubed. And this means that k value at point P is equal to the k value at point R. Both of them are equal to the same number, 2a cubed, yes? Okay, so this means that because these two lines have equal k values, they are parallel. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.